So there are like, what we will be covering majorly is the concepts of the container and the Docker containers. There are like other kinds of container as well, like CRI containers, but we will, the industry is 90% in Docker containers. So, I mean, this in containers and Dockers, we will cover concepts of container, why we use container versus virtual machine, bare metal. We will install Docker on CentOS, Debian, Windows. We'll see if you really want, we can go on Windows as well, but generally uh, it's very heavy on Windows desktop version, but it is perfectly fine. It works on Windows as well. But most of the uh, deployments and installations that happens on CentOS or Debian, Mac, not Mac, I mean CentOS or Ubuntu. Pretty much the installation is very straightforward. When you see the 2 Linux version, you will be okay. If it is a third one, you will be able to do yourself. Managing containers with Docker commands. So which Docker commands and API which we'll use to manage the containers. Docker Compose, I mean, it's a very good functionality in Docker, which allows you to do lot of container commands in one file. Docker registry, I mean, we will be using Docker Hub for registry. We'll see, I will discuss more about registry there. We will see networking inside Docker containers. We will also see like building our own Docker images and then using, running those as a containers. So this will be essentially in the Docker session. We will be mostly using AWS EC2 instances for this. I mean, from now onwards, mostly we will, wherever we need a root permissions, we will be using AWS. Right, so what is the expectation is from concept topic slides is you should be able to look at the deployments and you can tell whether it is using container or this is container based or this is a traditional method. Now, I mean, while on this slide, I would like to bring one more topic, which is very much popular in industry and which is a buzzword for digital transformation journey is when many vendor will come back and say that we have an application which is cloud native, or they will say that, yes, our application is cloud ready. This software, this release will become the cloud ready. Essentially what is happening is they are packaging their application into containers and saying that they are cloud ready. Essentially, there is a lot other elements to being cloud ready, which is certainly a different words. Is like being cloud ready means is being data agnostic, stateless, microservices, all those components. But container is one of the ticks in the boxes to be cloud ready. Now, what happens? So we'll look into what containers are. Like a container is actually a process which is isolated from other process. So if we can run a process on a Linux or on an operating system, and this process basically is not conflicting with any other process running on the same operating system, then it has its own space in terms of its file system, inter-process communication, devices, networking. And so this isolation concept is actually in a much more reformed or refined form is actually the container. And then it also uses few other features of like operating system for isolation is like control groups. Now control groups are actually functionality in the operating system which limits the amount of CPU, RAM, and other resources used by particular group of processes, which means maybe they are, for example, a container can have one control group. There are some like other capabilities as well, which is used by container, like some certain user processes cannot create low level ports, but I think containers have been given this flexibility. Now also there is SE Linux, which is used by container, which means is containers also, because containers have certain root level privileges, it is also a security threat. That means somebody can, as a user, run a container, which can then do a task which the user was never allowed the permission. So and that's where the SE Linux comes into the picture, is to put a mandatory access control in place. So that if a user is trying to do something with a container, which he should not be do it, then those securities should be in places. But SE Linux itself is a very wide topic, and there are different level of controls you can put in place on the operating system. So right, let's move to the next slide. So what are the advantages of using the container? Why actually do we need container? When essentially we were good with virtual machines. I mean, we had like bare metals, and then we can run on hypervisor on that, and then we have VMs, and it's fine, and VM can run application. So why actually do we need containers? So maybe I will skip one slide, and I can just do this one, which is actually, I will come back to that slide as advantage, because when I do the comparison, it becomes a bit easier to explain why it is needed. So traditionally, what we used to have is, on the left side of the screen is a bare metal. So we have a hardware. We can have a big, massive blade server, and then we will put an operating system on top of it, and that blade server will be hosting certain applications, and we will install the library which is needed for the applications. So, and then there was a concept of shared library as well. So if the same library is used by multiple application, then you use a shared library. And there is a limited capacity, right? So what happens in traditional, the problem was, you're running few applications, but you're not using the entire capacity of the server. So maybe you are not using full CPUs, maybe you're not using full RAM, maybe you're using more disk. So there was not resource optimization at that level. So next came the virtual machine, which is mostly on the right side of it, which we have hardware, and then we have hypervisor. And then on hypervisor, what we have is virtual machine A, and then we have virtual machine 1, virtual machine 2. So what means that same hardware can run multiple operating system, and then you can run your application on each VMs. So what it means is the same hardware can be utilized much more efficiently. You can have two different flavors of operating system, and you can have two different applications if they need two different operating system, or maybe two different configurations. Now what happens with the Docker is, now Docker doesn't necessarily, I mean, you can run the Docker in multiple, the containers in multiple way. Is you can actually run the, you can have on the bare metal, on the level of OS, you can install Docker service. And on top of Docker service, you can run multiple containers. Each container in itself has everything what it needs to run. All the libraries it needs, all the dependencies it has inside it. So once we have the container running, it is incomplete itself. So we will just pull the image, we do certain admin things, and then launch the container. So what it means is the most efficiently, I mean, it uses the resource very efficiently. If you are actually running out of, let's say, memory, it will not restart the new container. It will say the host system has actually ran out. So if you can say, for example, let's say you have 32 GB RAM on a server, you are already running two containers of, let's say, maybe 15, maybe like you're already using 14 GB of two containers. So you're using 28 GB, and then you want to run a 1 GB. Generally, you will not have that big containers, but just for the sake of argument, you have another 2 GB left, and you want to run another container, and you want to run a small Nginx server. Yes, by all means, you can run it. So you can actually mix and match the resources you need. Now coming back on the virtual machine concept is, now this container concept is not limited only to bare metal. We can also run the containers in the virtual machine as well. So what it means is you can still use the leverage of virtual machines, and you can also run the containers inside the virtual machines. In fact, this is right now most of the cloud providers are the way it is being used is like this: is there is a hardware. So if you see the right third option, almost uh, almost 90. I will not say that we don't have a figure, but almost everyone, wherever there is a hardware, there is always an hypervisor, which means on top of a hypervisor there will be a VM or a virtual machine, and inside that virtual machine is actually the container is being run. And there are two ways right now. What is being done is at the hypervisor level, there is a VM level orchestration and there is a container level orchestration. What it means is hypervisors like VMware, even in OpenStack, they have this flexibility now at a cloud level that if VM1 basically crashes because of any reason, they have this tool which can detect it. Like vMotion is basically sends a heartbeats back to the VMware, and it will spin up a new VM1. It will destroy the VM1. It will create a new VM1 and start the new app. So what it means is at any point of time, if there is a unavailability of a machine, at the hypervisor, at the VMware, or at the virtualization layer itself, this can be handled. Now, since let's say your virtual machine is very big in size, probably there can be a big VMs with like 20 GB RAM or big, depending upon the kind of project it is. So spinning those big VM will take time, maybe 5 minutes, 10 minutes, something like this. Right. So, and then other questions about the containers. We'll just go. I will just answer one question which is relevant to this. What we are discussing is what is a hypervisor. So, hypervisor is actually a layer of virtualization which abstracts the hardware from the operating system or anything running on top of hypervisor. So, typical example, there are two kinds of hypervisor. So, there is a class 1, class 2. And class 1 are the one which actually runs on the bare metal, and class 2 are which can run on top of operating system as well. So I will give you two examples. Class 1 is like ESXi. So you install ESXi on any bare metal, and from there onwards you can manage the hardware of the bare metal using a VMware console. That's a class 1. Like a Xen hypervisor, AWS uses a Xen hypervisor, which is a class 1. Now that's the class 2 hypervisor is something like VirtualBox, which you can install on Mac, on Windows, and then you can launch virtual machine from there. That's a class 2 hypervisor. So that's the hypervisor. Yeah, essentially, in summary, hypervisor is a layer which abstracts the underlying hardware from the running operating system. Just looking for. There was one question about the container. I will probably quickly answer. There are two of them. So one says the container has hardware. So I'm sorry, container doesn't have a hardware. It's all virtual hardware. So it creates a virtual NIC. It's all abstract hardware created like in VM. Like we create virtual machine on a virtual box. There is no physical underlying hardware. It's just a virtual interface created for an underlying physical hardware. So container similar to VMs doesn't have hardware inside them. Why is Linux container preferred over Windows container? I mean, this is a very good question. So let's do this one very quickly, and then we move on to the session. So what happens with Linux? What we need in order to run an application, we mainly need very core kernel features like scheduler or memory management, like IO management, IOs. So we need 3 or 4 main functionalities of the kernel. We don't need a very wrapper around functions. And Linux has this functionality where you can strip it down to a very minimum layer of image, just providing those functionality. And what is essentially needed to run the application. Let's say I'm running a web server, a very typical example. And for a web server, what do I need a complete operating system? Really not. I need only very basic features of kernel to run an operating system, and something, not everything, but few other things apart from Linux kernel, to run the operating system. So this that in Linux or in Unix, you have this Linux, you have this functionality where you can actually pick and choose what you want, and you can strip down to bare kernel functionalities. But in Windows, you don't have this. Everything is well integrated into one. So what means is even to run as a container, you will still need everything, which you might not need 60-70% of the stuff. And that is the reason why Linux container and are preferred, because then they are easy, they are flexible in the sense if you have to spin another one, the size is small, it will spin fast. And then and because you have removed all the overheads of libraries which are not needed, generally it will be faster than the other Windows container. So that's probably summarizes why Linux are preferred over Windows. But it means that necessarily you can run on Windows, nobody's stopping. The concept is available to every operating system. Doesn't say that you cannot use Windows. It's just that by practice, people have eventually come to a conclusion that Linux is better for all those reasons. Yeah, okay. So, sorry. So, there's one question which is, what do you mean by abstracting the hardware? So what I mean by this is when, let's give a real example, is like you have a laptop or you have a server. So what you're going to install on a server is either a direct operating system, and this operating system will expose uh, the system calls, which you can call using program to use the hardware. So that is what operating system has created, is a layer of abstraction uh, for the hardware using the system calls. So this means is it presents a way to access it. So hypervisor or ESXi is actually, what it does is it basically manages all the calls that goes to the actual hardware, and then basically anything that comes on the hardware, it manages which VM to send. So that's the layer, that's the abstraction layer. Can you please explain traditional approach and container with a use case or example? So yeah, we have a traditional example is all the hosted sites. Previously, there used to be a physical server, an operating system running on top of it, or maybe a VM, probably like 6-7 years ago, a virtual machine on top of it, and on that you have a application running using the entire operating system. That's the traditional approach, and the example can be any website, even the bank website before, or you can say, let me just think. Olden days, what was I mean, the famous Yahoo was used to run like in traditional approach. Yeah, so I mean, I mean, if you talk about mostly things from 2008, before they were all traditional approach. Then from 2008 to 11 and 12, it was all VMs, and after that, but from 15 onwards, I mean, it is like Docker, and 16. I mean, it's moving on more and more to containerization. Yeah, and now I mean the current example is everything is mostly on containers and Dockers. Every services are packaged in a container and shipped in a cluster, so that even one or two instances of those container is down, the other one is serving it. So now the approach is more scalable, which means you wrap around one service, you create a service, and then you wrap it around in a container and put it on a cluster, and the cluster manages the service and the container, and then cluster itself is running, including 3 or 4 VMs, which is called nodes. So we'll look more into detail as we move on to the next topic after this, is Kubernetes, like cluster management. So so what I was trying to give you right now in current market world, the third choice, the virtual machine option, is the option which is being mostly run. But right now, all the VMs they generally have a Docker, but they also have a cluster management, like they manage Docker clusters as well. That's we will see in the next slide. So pretty much mostly Docker is kind of base package needed on most of the VMs for running containers. Now, come back to what advantage that container brings. They are flexible. That means if you have any application, you can put it in container. Now, we all know that the new applications, yeah, they can containerize because they will be architected according to that. Even I've seen in practical field application, big Java application, that there are data warehousing application needing like 4 or 8 GB of RAMs. They have been containerized. So that means you can have a container of a very big size as well. There is no limitation, but it defeats the purpose in terms of usability and practicality. But yes, big size application can also be containerized. It will not be very efficient, but it can be done. Lightweight, I mean, if we go from the point of view is a general best practice recommendation, the containers should not be like more than, I mean, the ideal is maybe 512, half a GB or 1 GB, maximum 2 GB, but not more than that. So inside the container, even the OS size is very small. We will see this later in the exercise. The operating system used inside the kernel is not the standard 1 GB, 2 GB operating system. It's just the bare bones. Some of the container doesn't even have basic commands like netstat or netconfig. So they strip down only the commands that is needed for that application to run are added onto the base OS image. It's portable. So yes, it's once the image is built, that image can run anywhere. You don't have to actually worry about where it will run. So it can run on, it will be exactly the same environment. You upload it on the registry, and from the registry, anybody can download and use it. Scalable, you can create as many number of container as you want. It's not just you can only run once. You can run the same image again and again. I mean, there is a way to do it. Is you will change the port or whatever service is exposed on inside the container. You will map the port to something else, and it is secure. The containers are already secure by SE Linux, but you can generally what people do who are security paranoid is because these containers will be running everywhere. They only put only the bare minimum necessary libraries and function inside the container. What is needed for that specific app. I mean, that's like bare minimum. Most of the production grade, this is I'm talking about the production grade. Generally for development, development people needs many debugger tool inside the container because they need to see what is happening. They are debugging the application. Sometimes they need to put breakpoints in the code. So they have much more, the development images have much more utilities inside the container compared to the production. But once they are happy with that, the image which is published for releasing, they will strip down, take out all the utilities which is not needed for production. So make it secure as you basically create your container with the limited access which is needed for application. Now, what actually the container image is actually a file system. So which can be used to start a container. So it is basically a snapshot kind of thing, not exactly a snapshot. What it contains inside the container, it will contain your application code. It will contain necessary shared libraries to run that application. It will contain the commands, like if you want to, I mean, how will you finally launch a web server? Let's say we were seeing in last lab was Python and then the app.py script, so something like that. So we need those commands, OS level commands as well, and whatever internal command is needed. Any kind of runtime services. So if we run a command and that command needs another services to be running, those services needs to be packaged inside the container. So any kind of dependency. So that is part of container image. So what you can say is, if I say I've created whatever web server I created, I can create a container for that. And I say, okay, this is a container image, rather than trying to clone the repository and then install the Flask and install Python. Python was already there, but if you're running on local, you will be installing Python, then Flask, and then running the command. what I will say is, okay, here is my container. You basically take the container and you take the container image and run it anywhere and it will work. So you don't have to do anything of installation. It is already done as part of the container image. So, I mean, this is generally the container concepts. But then since we have talked so much about what the container can bring on the table, why actually do we need Docker then? What Docker brings? Um, why is Docker so popular as well? So Docker brings an interface to manage a container. So I think we have covered this slide. So I will go here. So what it becomes, it brings any kind of functionality which is needed to manage containers. So be it what we talked about is segregating namespaces, kernel namespaces, process space, memory space, IPC communication inside the container, all those things. But all that is in container image. How will I manage container image? So Docker says, okay, I will provide you an easy solution to do all those things. This is where the Docker comes as a solution provider. Sorry. So what Docker contains in itself is Docker has three main components. It has a server, which basically runs, it's a client server kind of functionality. So Docker works in a client server model. Server is actually run as a daemon process. I mean, daemon process in Unix is a process which is always running, never stops. You can start this process at the time of restarting the machine. And it's like the server, like a web server is running whenever the node comes up. So it's like, and those processes are called daemon process. And it's part of systemd, as part of startup. So it can be done in Windows as well. But generally, the terminology of daemon process comes from Unix background. The name of this process is called Dockerd. So this is a server process that runs on the host machine. Then it also provides a command line interface, where you can say this server process has an API, and that API is exposed using a CLI, and that CLI can be accessed starting any command with Docker. So if you are on a prompt, or if you are on want to use Docker command utilities, you will type Docker like we were using Git. It was like something like very similar thing. You type Git and then we type clone. So Git basically is a command which which is interpret. And Docker is exactly the same. You write a command Docker and then you give basically give any kind of action to the Docker daemon. And then it implements a REST-based API, I mean, which is actually implemented inside the server. So every time you write a CLI, which is interface, a REST-based interface, which sends the command to the server, server interprets it and basically does what is the necessary action. So as you can see, is server is at the heart, then the API, and then the CLI. Now there are four other things which Docker does apart from having this three functionalities are part of the Docker software. It has images, it manages container, it runs containers. It also uses data volume, and it also manages a bit of network. So all this is done by the Docker daemon server. So whatever command we do and how we want to manage, these four components are also managed by Docker. Let's move on to the next step is what is the Docker architecture. So here I will try to give a bit of a flow what happens. So there are like three main components. Anywhere we are running Docker, there will be the host machine where actually the daemon is running. So generally it is the same machine where you install the software. So that's called the host. Then the client can be the same machine, can be the remote machine, but mostly it is also on the same machine. And we have a third entity which is called registry. So we'll see what is a registry now. So the registry is a new word. So client and host is still fine. What is a registry? Registry is a web server, which is actually not exactly a web server, a server which can communicate on REST. It doesn't have to be a web. And that has a copy of Docker images, which means you have a pre-built images of people application and which is put on the registry. So very famous registry is Docker Hub. Docker itself has there's a registry which is called Docker Hub, and they have a web server fronting the registry. That means you can log into the web server. It will give you the list of images which are available, which is public images. That means anybody can basically go and upload an image, and then next person can basically pull the image and use it on the local laptop, which is very nice as long as it's all everybody is good. But somebody just creates a bad image and you start and you run on your local laptop, it can steal information from your local laptop. It is because it's not a secure image. It can do anything because Docker has certain root level permissions as well. So it's risky as well. So public repository is a good way of learning, but it's generally not a best practice in industry. So most of the operating system provider, they provide the base images. So like CentOS base images is provided open source. Red Hat publishes a base image, and then from that base image, that means the minimum kernel which has very, very basic utility, just the kernel functionalities, and then whatever is needed, anyone can basically use it and then create its application. So best to start from there. So that's the registry. Now, while we are on this node, I will discuss more about registry in a separate topic. But then for now, you can just imagine it's a big database where all the images are saved, and you can access the Docker daemon can access this database. So what I will just cover like a few basic commands is build image, pull image, and run image. This is the most of the times we will be using this. I mean, not the command is actually not the build image. This command is just like build, pull, or run. So when a CLI can or client can issue a command called build, and this command will basically reach the Docker daemon, and then Docker daemon will understand, okay, I have to create a new image from scratch. What it will do is it will create a new image, and it will keep the image on the host itself. So you can see here there are like two Science Ubuntu and Nginx. So this basically images are saved on the same machine because the Docker process received the command. Now, for example, but somebody doesn't want to build an image. He says, okay, I don't want to build an image. I have already built it yesterday, or maybe my developer team has built the image and I just want to use it. So he will issue a pull command. He will say pull image from the database. So he can tell the Docker daemon process, okay, pull the image for CentOS or Nginx. And Docker daemon will basically go into the registry database and basically download that image and bring it onto the host machine, right? So that's the pull command. Then the third command is run the image. So what it means is, okay, you run the command is you tell the Docker daemon is, okay, let's say in this example, we'll say run the CentOS image, run CentOS. So then Docker will first check, okay, do I have this image in my host? And he will say, okay, I don't have this image on my local host. So it will go to its registry database and will say, does the registry database has sent this image? Again, you will find, yes, there is an image. And then it will automatically pull the image and bring it on the local host. So it will download the image on the local host and then run this as a container on the host. So the run image inbuilt, the Docker server will do all the three commands. It will basically, it will do the pulling as well and then running, just the two commands. It will not build because it's already there. So this is generally how the Docker works conceptually. As we go in more in detail, we'll see more, but this is the general concept of the Docker architecture. These are three main components. So before we go on installing, I will take the questions now. So I did till 4:46. Okay. So for a so I'm going from 4:50 p.m. So for a Windows container, The resource requirement might be greater because it requires OS. Yes. So the question is, underlying OS is taking up the required reports and the container still would require the same resource as a Linux time container. Yeah, okay, maybe it's not very clear. So if it is a Linux time container, it will use a different operating system. It will not use, so for Linux operating system, they have two different version. You have a desktop version and you have a server version and you have a base image, which is published. So base image is very, very small and it uses a very minimum resource. So we will see that more in, I will show that when we run the few commands, or how much difference it is, and they can decide from there. Technically, there is no challenge to that. You can either use Windows or Linux or any operating system. There is no limitation from the technical implementation point of view. But then it is what is more optimized, better solution. When you go for a production grade cluster, which is massive, then it might not be the best option. That's a secondary, but there is no technical blockage to use Windows. Is there any difference between container and Docker, or they are used interchangeably? No, there is a lot of difference that we just explained now. Docker is a way to use container, and container is a concept. And tomorrow there can be any other company, and you can say, okay, rather than using Docker way of images, you can use my way of images. So it's just a implementation of managing containers. Can a software development's desktop interface be containerized? Can a software developer's development desktop interface can be containerized? What can be containerized is your entire. I mean, yes, why not? But is that what you want to run as a container? I don't think. You will do a lot of work in order to have a desktop environment, development desktop interface. I basically, I don't understand what do you mean by when you say developers development desktop interface. Is it the IDE you are talking about, or a develop interface is an interface? So probably you need a web server running or something. But in essentially, yes, it can be containerized in the sense that you will take the base image and you will keep on adding the layer to the point where you need everything for the development interface dependency, and then you can basically run this as a Docker image. Yes, it can be possible. Does the Docker-D runs inside the container on the host machine? No, Docker-D runs as a daemon process. It's not runs inside the container. It can also run inside the container as well. It depends. But the way we will see is mostly it is run as a service, as a system D service. So Docker-D is mostly 99% I've seen it is run as a service, but I don't see why would you run. I mean, there's no point in running it as a container. Does a Docker Hub has to be an interface? Has to be in the machine? No, Docker Hub. Okay, sorry, maybe I was not clear. Like Docker in the same machine. So what is a Docker Hub? Let me show you now. Docker Hub is a web interface. So this is a Docker Hub, and this is actually the Docker own image repository, which they call Docker Hub. And then you can search here, let's say for any image. Let's say I want to search for CentOS. And there is, and this is, as it says Docker official image. So this is something officially, it has not been corrupted on Melphone. And look at the size, it's like 500 MB. It's the size of the operating system we're talking right now. We'll see more and more when we use it in after the deployment. So maybe I'm trying to understand your question, so Neil, is when you say has to be on the machine, not necessarily. The thing is, wherever your host is running, so I will come back to this slide, container here. If you come, the host should be able to connect to a registry. It can be a Docker Hub, it can be a private hosted registry. So like Many big enterprise, they have their internal enterprise level registry hosted. You can even have a registry inside a cluster. So it's not very complicated to have your own private registry. That means whatever work you are doing as a Docker image, you upload, you push it to that registry, and you only have an access in your private network. It's just a registry. It's a database exposed with a REST-based API which can interact with Docker daemon. So not very complicated, but anywhere we are running Docker host, it should be able to connect to a registry database, but not necessarily with everything, but wherever you are storing, wherever you want to access. What is the difference between Docker Hub and a registry? Docker Hub, if you see here, it's a name given to a registry hosted by Docker and which has a web interface. So this web interface is called Docker Hub. Behind, they have a hosted registry, which basically stores all this database. Essentially, you can have your own registry, which you can call your name, and it can save the same image. You can copy this image, like download this image of CentOS, and you can put in your own registry. And when you want to run, it will contact your registry first. And if it cannot find, it can contact Docker Hub. Right. So at Sunil. Okay, Abhinav was trying to answer, which is good. Presume Docker Hub is one of the registries. Fine. Is there any enterprise registry which ensures that images are clean and harmless for the host? Yes. Red Hat itself has their own enterprise registry where they publish images. Many organizations have their own enterprise registry, like almost every big organization have their own private registry, and they recommend all the teams. So it is like this. I can give you an example in Cisco or Microsoft. What it happens is there is an IT team which will host something like Docker Hub. They will have their own internal private registry, and the IT team will make sure that whatever image is pushed there, I mean, they will provide you the base images, like here Docker is providing you a CentOS official image. Their IT department will make sure that whatever base image OS is provided is safe and secure, be used for any development purpose. For example, a few companies have an hardened version of the base OS. That means they have removed any kind of security vulnerability published on the internet, created an image, and they push their image on their internal Docker registry. And all development team basically access that image. That is their base OS from where they will start to work. Right. To the next question is, host is the machine in which the user has logged in. Yes, host is the machine where basically will install the Docker. That is the host. Database means will that be an image or any DB? Database I've used in the terms is not an RDBMS. It's not a relational database. Database is a collection of images in terms of is the database, which can be accessed over a REST-based API. So that is in terms of database means a collection of registry, a storage. Are client and host meaning the same machine area? The client and the host in Docker generally they are run on the same machine. So the server is running as daemon D, and then the client you will run the command on the same host as a Docker. So Tushar says IDE. Yes, you can containerize the IDE. Yes, it is quite possible. But it will probably I don't know, even if you run it as a Docker image, you will spend more time to build that container image than basically just use ID. But yes, it is quite possible that you just pick up a base CentOS. I'll just take an example of PyCharm, let's say as IDE. So use the base CentOS or any image, and then you install PyCharm, and then basically run this as a Docker, and then you can connect it. But can you export your display and all those things? You will have to work out those other dependency. Yes, you can. I mean, as you go on, you can build your dependencies tools inside that image. Yes, it's a good use case. I think many developer might have it depending upon how they use it. You can have this image published, And then wherever how you want to access it depends on, you can do Docker pull and then go inside and connect it and expose the display port to wherever you are. The Docker image contains a highly stripped down OS. Is this understanding right? That's correct. So it's a very, very minimalistic operating system. How can an enterprise registry be built, and what open source host can be available aside from Docker as an API interface to the client? So registry depends. Registry, if you are building a registry, you will have to define or take a choice that which technology you will use, whether you want to go with the Docker or any other container APIs. 90% people are in the industry, 99% are using Docker. So it will essentially, what you will see is you can Google, and there is a very easy way of creating a registry set. It's a software which you can download and install, and then it becomes a registry, and you can copy the images over that. So maybe let me take a note. I can see if I can quickly cover this as part of one of the exercise, or I will demonstrate how to do it. So what we're talking about?
Yes, thank you, Professor. Yes, I'm very interested in that.
Okay. Enterprise registry. I mean, creating a registry locally. Then Suhas, how we are moving the containers from one environment to another through Docker? If yes, how does Docker travels? Like should we have to package and deploy Docker to cluster and single machine? Okay, so there are many questions, so I will just take one by one in this one. How do we move the container? We don't move the container, we move the images. And when we run the Docker run command, it actually take the images and run as a container. What moves is the image. Image is kind of a snapshot, or you can say as a file system, Docker volume file system, which basically moves. So what we see here is image of 500 MB is just that you will download a file, and then this file is used to launch a container inside, and inside the container is CentOS operating system. So container doesn't move. Container stays where it is. Its lifetime is as long as it is running on the host. If it dies, it has to be rebuilt using the image, and everything inside the container is lost. So once the container dies, everything is done. There is nothing left. So you'll have to. The only option is you restart your container with the base image, whatever was with the old container was started. All the packaging and the deployment work is already inbuilt in the image. So when we build the image, we put the necessary packages, deployment commands, and everything inside the image itself. So when the Docker is trying to run the image, it will execute all those commands at the time of running the container. So that's Suhas. And okay. AWS EC2 instance auto-scaling works on the same concept. No, EC2 auto-scaling, I mean, it's a slightly off the topic question, but EC2 scaling is completely different. It works on the concept of vMotion, which means that a virtual machine is missing, and that means it will spin up a new host, a new operating system of the same size. It's not container, it is it's a different concept. Can I answer? Yeah, so Sandeep wanted to answer the question about the development environment. Sandeep, go on if you want to.
Hi everyone, is my voice clear to you? All right, so there was this question, and I mean, I'm really impressed by the questions being asked in the session. So there was this question related to, can we have a development environment inside the Docker image? All right, so it's a very interesting question. And when I was at Amazon, and I was in the Amazon detail page. So what used to happen is that whenever a developer joins, and developer joins very often and leaves very often at Amazon, we needed a development environment to be ready very quickly. So since we worked on the website, the website is huge, and there are a lot of moving parts in the website. So so what we used to do there is there will be two parts, two kinds of handover, that two kinds of, you can say, two kinds of assets that we get is, one, we will have a virtual machine in the cloud in which there will be full image of the website, and there will be a desktop which will be given, physical desktop, as well as a cloud server which is given to us. On the cloud server, where we will be cloning the entire website, while on the desktop we will set up the Eclipse, right? So now while you can see that on the server side we have a virtual machine running on the cloud where the entire website is there, but since installing a virtual machine on the desktop and then running Eclipse inside it and other IDEs inside it makes it extremely slow, so it did not make sense to put virtual machine on the desktop side. So the quick answer is yes and no, okay, to that question related to the development environment. Yes, we did have the development environment on the cloud in the virtual machine, but not really a Docker image. But now I think they have moved to Docker because that is way more scalable, and or maybe it's still the virtual machine, okay, thick virtual machine. And on the desktop, no, we did not have the Docker because it was, or a virtual machine, because the IDEs become laggy. All right, so I hope I was able to answer your question regarding the development environment. So the answer is we did have on the cloud, which was basically a virtual machine, not really a Docker image. Maybe now they might be moving, but most likely not, because the Docker image is something that we would like to move and deploy, not only develop. So in some cases, people do have the Docker image for their production ready software, but or the software that needs to be deployed. But development environment either are inside the virtual machine or normal installations on the desktop. Question from Rizwan is, how were you handling high traffic database connections, web crawlers, and bot? For which we had Docker-like in deployment, or you can say at that point of time, we did have most of the EC2 scaling. EC2 scaling by the way of what do you say? By the way of hyper virtualization, or the virtual machine that they call. And so as Ashok described related to the EC2 scaling, that's the model we use to scale the website on demand. And also with respect to the web crawlers and bots, we had, for some of the distributed denial of service, we had the firewall in place. And for the high traffic database connections, we did have many instances running, and as we detect there's a huge traffic, the server will scale up. Also, please note that in case of Amazon, we are generally ready for the crawlers, because our website is hit almost like every couple of hours by the crawlers and bots. So we are generally ready with handling that kind of traffic. But for denial of service, we had a separate security mechanism to detect and defend against denial of service. While crawlers and bots are something natural, which we want to support, or for that matter, any website would like to do that, because the Amazon, it was the 10th most popular website on the internet, the Amazon detail page, and the reason was that most of the traffic used to come from Google itself. So it was very important to support all kinds of crawlers, because that's what makes the sales. And yes, so most of the scaling was the standard EC2 Elastic version way earlier, but probably now they have moved to Docker based or Kubernetes based models. All right, sorry for a long answer.
Okay, thanks, Sandeep. That was in fact very detailed answer. So now, I mean, I'm looking at the time as well, and the idea was to go for AWS Bootcamp. So we will quickly try to. So I think there is a question from Sunil. My question is not framed correctly. I'm trying to understand how Git and Docker are used in a life cycle when the application or service is ready for release. Git can. Yes, I think Sunil, it's where you are getting in, because what you will do is you will package your code in a container image. Then as part of CI/CD, you will deploy the container on one of the hosts. Then you can actually either spin this host as part of one of the triggers in the deployment. So what it means is you will only spin the host and run the container on top of it once you think it is ready to that stage. So that can be integrated. Yeah, your understanding is correct. In summary, so we'll just we have 3 minutes for the session, and right. So I think there is a comment from Anup is to that a lot of reading to do, and we can do next session. So I'm not going to go in detail on what basically on bootcamp. Nothing new will be covered. It's a demo to show how to use it. So which means when you are going in the week you're trying to play with, you have actually seen the screens once, and then you can actually launch the instance. So I will quickly, I mean, maybe I can show you directly on the server. So I'll quickly show is when you actually go on create account. This is something you will get is create an AWS account, and you will fill in your information. When you go to the next step, it will ask you what kind of account you are opening, personal and all those things, which I think pretty much you can do it. So once you are actually logged in, you will go on AWS console. Right. So this is how the console looks like once you are into AWS. Now I'm going to cover the slides as well, and I will share the slides because this will help you. Can we please hold for the day? Yes, I think let's hold for a day. I'm going to just take 2 more minutes, not more than that. The idea is I want to share the slides and walk you through on how to launch it. So maybe just, and what I'm trying to show you, I will share that in the slides as well. So you first of all, you go on, click here. All those screenshots are there in the slides, which will be shared. You select a region which is closest to you. For my case, it is here. So I select EU. And then I go on services, and I select the first one will be EC2. And you go on running instances. I already have an instance. So just forget about this one, and we'll launch a new one. So you just click on launch instance here, and all you have to do is keep going, saying next, next, next. It's generally so straightforward. There are a few places you need to check, which is clear. So you go here and you search for, let's say we want to do install on CentOS. So you search on CentOS 7. We can use 8, anything, doesn't matter. It's just that I was used to it. You can use 8. And what you need to make sure is you go on free tier eligible. Use the one which is free. Don't use anything which is not free. Don't use something like this which is paid. So use a free tier and then select that one. It will bring you a screen. It will show you the payment. But if you have signed new, and this is your first time signing up with AWS, you will get free CPU cycles, which will be enough. And then you click continue here. It will bring you to the next images, choosing the size. Again, choose T2 Micro, which is the free. This is the only one free eligible. Just choose this one and say review and launch. And when you click here, and just it will say hardware cost, your fees is 0. And then you'd say launch. And it will ask you to create a new pair. And what you do is you say create new pair, just give the name, is let's say AWS. All this is in the slides. You don't have to watch it now. Everything, all these steps, screenshot is in the slides, which will be shared. You can download the pair. Always save this pair. This is very important. If you don't have this pair, you won't be able to connect to your instance. You can, but it will be much more tricky. But necessarily you need to download this key. And what is going to do is basically it will launch this instance. So as it's saying pending, it will take some time and we'll have it running. So that's it. That's what I wanted to show. And this is what is covered in our AWS Bootcamp slides. So quickly, I will just walk you through. This is the registration, account registration details. You click on the link, go there. Step 1, select your region which is closest to you. It will make its access faster. You click on services, EC2, and you can see which availability zones are there in the region. If you scroll down and below on the service health dashboard on the same page, here it says it's operating manually normally. Next is it will show you your CentOS 7 free tier eligible, the screen, and the operating system license. The security group, you just it's basically a firewall. You don't have to worry about it. We will use it, the default one. In the next session, before using it, I will basically we will generally terminate the session, terminate the instances once we are completed. We don't leave it running. So we will use wide open ports for now, which is not recommended. So once I will launch in the next session, we will configure it to the necessary ports we need, or we will leave it wide open. We will use it for the session and we terminate it. So either ways, the idea is don't leave a box running with a public access. So next is you get this screen where you select the CentOS 7, then you click continue and select the T2 Micro, and finally you click launch, download the key pair, and bingo, you have your instance running. Now, once your instance is running, I can show you on the terminal if I have instance running here. Just click on this connect icon and it will show you how to connect. Follow this in steps. Either you are Windows, Linux, doesn't matter. You just have to follow these steps. If you don't have a PuTTY, or if you never used PuTTY, you just click here. It will show you how to connect using PuTTY. I will cover it in my session as well. I just want to give it a try. If you basically try, so you might, if you're stuck, then I will just resolve the problem. But I will show you how to connect. You just do this step and you will be able to connect to your site, to your terminal. So that's what we want to do is we should be able to launch. We will do this in next session as well. Okay, so now, I will stop here and I will share this AWS Bootcamp slides and I will continue next week. Okay, so there are a few questions I will pick up now. If anybody wants to drop, they're free to drop. I'm not going to cover any topic. It will be generally the questions and one-to-one queries. So how many months we need to use AWS? I think if for any reason we are running out of your subscription, you can use a different email address and a different payment card, and it will give you a new free 12 months session. Generally, we will be needing it till the month of June, but essentially I will say is the more you will practice, the better it is. It's not necessarily that you have to use AWS. You can use GCP, you can use Azure. All you need to know is how to launch a virtual machine. You can use DigitalOcean. There are many more cloud providers. All what you need is basic is you should be able to launch an instance on that particular cloud provider and connect. That's what it needs is. Right, and this last question is the images you're asking about, Rick, is yes, different availability zones have the same image. Different regions have different AMI copies. They are exactly the same software. The only difference is the AMI IDs is different in different region, but they're exactly the same. So from that point of view, it doesn't really matter. I mean, as I said, as long as you can run the operating system on any cloud provider, that's good enough for the purpose. Okay, so we'll stop here and we'll reconvene on next Saturday, the same time.